like it is now the top of the hour, so I'm going to go ahead and get started. Welcome to part 2 of Citizen Science in the Academic Library. It's great to see you back today, or if you weren't able to make part 1 last week, then welcome, and that is not a problem. You'll be able to follow along today, whether or not you were attending at part 1 last week. My name is Kelsey Coles, and I will be your host again today. Before we begin, I have a few quick housekeeping items to cover. These are exactly the same as last time. We are hoping to get a captioning link very shortly. As soon as we have that, it will be in the chat box. Our captioner has been having some trouble getting into the webinar. We are working on it. You are all muted. Please ask any questions or make any comments you may have in the chat box. We will be taking questions at the end of the presentation, but you can type them in at any time as they occur to you if you prefer. Please do make sure you're sending to all participants when you use the chat box. This presentation is being recorded, and you'll be emailed the caption recording once it's available, along with the slides and the resources guide. Today's slides and the resources guide can also be downloaded from the class page, which will be linked in the chat. You're just going to scroll down to course materials to see the download links for those. Just a heads up that the resources guide that's posted has had a few resources added to it since last week. So if you downloaded it last week or before today, please do go and download the new version. This webinar will grant 1 MLA CE hour. If you wish to claim that, you can complete the short evaluation that will open once you leave the webinar. If this evaluation doesn't open for you for some reason, just send me an email. My email will be on the last slide, and I can get you the link. Please do fill out this evaluation even if you're not seeking MLA CE. These give us really valuable feedback on how we can improve our offerings. Additionally, Caroline from SciStarter will also share an optional evaluation survey with questions more directly related to the content of this series at the end. And so if you're willing to fill out both of those surveys, that's amazing. You're not obligated to do so. So before I hand things over to our speakers, let me take just a quick moment to reintroduce you to NNLM in case you're not familiar or you couldn't make part 1. So NNLM, or the Network of the National Library of Medicine, is a part of the National Library of Medicine, and we're dedicated to outreach, engagement, and training. One of our most popular services is the numerous free webinars we offer, like this one, which are tailored to audiences ranging from academic librarians to public health workers, clinicians, researchers, pretty much anybody working with health information. Our trainings cover a huge range of topics, and we're always coming up with new offerings. And we also offer funding opportunities, free informational materials, on-demand trainings, and more to our member organizations. NNLM membership is totally free. I work in the Middle Atlantic region. I'm based at the University of Pittsburgh Health Sciences Library System, but there are 7 other regional medical libraries around the country that will be your contact depending on what state you're in. You can visit nnlm.gov to learn more about us and what we can do for you. So one of the areas NNLM has been working in for the past few years is citizen science and crowdsourcing. And last week, our speakers covered what citizen science is, how academic librarians can work to support faculty and students who are using citizen science in the classroom, and where you can learn more about citizen science and how to get started. This week, we're going to take a look at how to support faculty who are interested in integrating citizen science into their classrooms, how to work with faculty as they develop their own citizen science projects, and where to access and how to utilize some more resources and engage with other librarians doing this type of work. So just to start us off with a little audience participation, we're going to do a quick poll. So please tell us in this poll if you participated in last week's webinar. And if you did, take a second to type in the chat box if you've had any new ideas for how you might want to or how you plan to use citizen science in your work based on what you heard at last week's webinar. And if any of the hosts want to, or the panelists want to read and react to any of the comments in the chat, please feel free to unmute and do so. So I'll give you a few minutes to answer the poll and use the chat box.
Someone says, look for citizen science with food and agriculture. Very cool. Yeah, I think agriculture is such a place, like, we need to get more people involved in agriculture, involved in citizen science. It's such a great way to plug it in. So if you go, are part of a land-grant university, for example, that could be an interesting tie-in there.
Yeah, shameless plug. Right now, NC State researchers are doing a sourdough starter citizen science project where they're asking people to start sourdoughs inside their home and outside and then report on characteristics. I'm going to look up a link for you real quick, but
right, I have it
out there. Oh, perfect.
They wrote a blog for SciStarter. It was such a fun blog post.
I
just put it in the chat.
That's super cool. I have a sourdough starter myself, so maybe I'll have to participate in that project.
You gotta do it. Yeah.
I'll do it.
Let me know how it goes for you. Someone says, I am not in an academic library, but I work with and I love our librarians. I had not thought of using our library to house citizen science materials that people could check out. So someone was inspired.
Yeah.
Awesome. Cool. Yeah, so it looks like about 2/3 of our attendees were here last time. So that's awesome. Thank you for coming back. And for the folks who were not here last time, welcome. And you will be sent the recording of part 1. So don't feel like you missed anything if you couldn't make it last week. All righty. So without further ado, I'm going to hand it over to our first speaker, Danica. So take it away, Danica.
Hi, thanks. And thanks for folks who returned for part 2, and welcome to folks who are new. I'm Danica Lewis. I'm the Collections and Research Librarian for Life Sciences at North Carolina State University Libraries. And I started at the libraries as a fellow working to support citizen science, really as a way of supporting broader impacts for grant requirements. But it turns out there's so much more that you can do with citizen science beyond just that. And it quickly ballooned into a whole lot of other really, really exciting things. So as far as course integrations go, sorry, next slide, please. Oh, there we go, great. So as I was thinking about all of this, we've worked with a lot of courses, and it's fortunately for us, unfortunately for like a well-structured presentation, it's happened really, really opportunistically. But the course integrations that we've supported kind of fall into 3 main sort of categories, and they definitely overlap and interact, but there's sort of a different emphasis that courses can have. So there are courses that have a research agenda, but they need participants to help collect or analyze more data. So these courses usually already have a study design, and they might have been doing this for years, but they just need help recruiting and managing contributors or distributing project materials. So examples would be a mammalogy course we worked with that had been using camera traps to study species diversity in a remote research site, but they wanted to generate comparative data in an urban setting, and so they needed volunteers to help do that. And then we worked with a metagenomics course that had been sampling swabs of students' sinks, but it was only a 10-person class, and they wanted hundreds of samples and didn't feel they had access to that many sinks. And so we helped recruit students from other courses and students on campus to go and take those samples. So our largest and most successful projects have generally started with courses like these. And that's not to say that it's a required starting point. That's just how it's worked out for us. Promoting these projects to campus at large ended up being a conversation starter for other faculty who were interested but maybe didn't know where to start or didn't know that there was support for starting. And so that's just generally how it's worked out for us. So another type is the course that needs a project. And these are usually the faculty who contact you as soon as you say, hey, you know, anyone on campus interested in participating in this? They're usually looking for a project or multiple projects to participate in, but they don't necessarily have a fixed research agenda. So lots of introductory courses will have a research experience component, but the details of that research can be really flexible. So citizen science is an easy way for instructors to offer a range of options and encourage students to pursue their specific interests and sort of take ownership of their own learning without having to design and run a dozen different research projects of their own. So we've worked with introductory environmental science courses as well as our first-year writing classes on these kinds of projects. So usually this support looks like helping to find a range of projects that will all work well for an existing course assignment, providing customized library instruction, and then connecting them with other faculty on campus who are either integrating citizen science in their own teaching or in their research. So, and then finally, there are courses that need case studies, but designing or participating in the project isn't necessarily their end goal. So this can look a lot like meta-analysis. So we've had graduate students from the College of Engineering who studied the student outcomes of participating in citizen science projects, or we've worked with a microbiology course where students needed experience working with nucleotide sequence data, but not necessarily collecting or processing it themselves. They just needed sequence data, and they were thrilled that it was data collected on campus by other students. So again, we made these connections by promoting existing projects, and then faculty contacted us, and the support we were able to provide was primarily making that connection back to the TI or to other instructors, and then just sort of like tweaking existing library instruction. So next slide, please. So one of the first thing that's important to establish, identifying projects, right, for those classes that that need a project to participate in, it's important to establish, as far as expectations go, whether or not this is something the faculty member you're working with would want to publish on. Citizen science is a bit of a gray area with a lot of IRBs, and because you're working with students who are a protected class in human subjects research, and they're not necessarily the focus of the research, but you could be collecting secondary data about them, it gets really complicated. So it's important to talk at the beginning and make clear that this is a class assignment, so it doesn't require an IRB. But to publish or present about it, you might, better safe than sorry. This has been a deal breaker for some faculty that we've worked with, right? And for some projects, the faculty chose not to do an IRB and then kind of regretted it because the project outcomes were really cool, and then suddenly it was a little tricky about whether or not we'd be able to publish on it. So since most of the projects qualify as being low risk and the human subject aspects are usually minimal or secondary to the actual research, it's worth it to talk with someone at your IRB office and get their take. It usually doesn't require a full review, but there's too much variability to ever be able to make a blanket statement. Citizen science is a huge priority on our campus for faculty as researchers and as teachers. And we've had lots of meetings with the IRB to try and figure out if there's some way we could do a blanket proposal or a blanket proposal for projects, and it's just way too variable. So you do need to have a specific conversation about what that process is going to look like, and then make decisions going into it knowing what the limitations are going to be on how far you're going to be able to talk about this. So the next expectation is time. Creating a project from scratch takes longer than designing regular research because you also need to design participant recruitment and management and coordinate with other classes' projects. So if you've got two classes that are doing this and one's collecting data and the other's analyzing it, that means that the syllabi have to line up and have to follow the same timeline. And in some cases, that meant we were planning a year in advance before the project actually went live. And so time can be a huge consideration. Once big picture concerns are addressed, typically if you're looking for existing projects, I cannot recommend the SciStarter Project Finder tool highly enough. You can search for projects based on discipline or location or online components or extra features like pre-existing lesson plans or apps. You want to consider how long it should take students to participate because there are different levels of commitment and investment in training across projects. and you should consider what levels of technical expertise they might need and make sure that those line up with course goals. For the English, like first-year writing projects we've worked with, they wanted a whole spread so students could choose what they were interested in, but then how do you make it sort of fair between projects if some are really, really involved and you have to collect weeks of data and do training and all of this, and others are you make a couple of identifications through an online portal, right? They're both really interesting, valuable things, but you have to sit and think and work out with instructors how to make sure it's the same amount of work for each project. So which brings us to identifying related resources and materials. On the next slide, please. This is another sort of in line with identifying projects, but I pulled it out into its own slide because this has been one of the bigger challenges that we've come up against with supporting classes when you're trying to identify projects to use or to set up your own. You have to consider what materials students will need and how you can get them access to those materials. So this is one where the library can really shine, and that always feels great. But it's also one that can sneak up on you and has snuck up on us a couple of times. So the library can help, but we need a lot of lead time to add something to tech lending, and you need to make sure that you're in communication with the people who manage those programs. Last week I shared some of our ongoing challenges around distributing teaspoons of glutamine, which is an amino acid needed for the Ant Picnic project. It also happens to be a white powdered substance. If anyone since then or in the future thinks up a way to give college students baggies of white powder while looking like you're definitely doing science, please email me. Some of the challenges are really straightforward. How do I convince tech lending that they really should buy a bunch of magnifying glasses on rubber bands? And others are that nebulous, like, sure, we can buy glutamine. How do we give it to students? So a lot of this work focuses on facilitating or amplifying the work of faculty trying to get this started, because there's a lot of extra work to getting that all rolling, and you're going to hear more about that in a little bit. But funding is another area where the faculty we've worked with have had the contacts to get educational grants or donations from companies that they work with, but the library can step in and help reduce the workload and get, if they just give us an email introduction, then we can do the explaining and the asking for donations and the writing proposals, and that just makes it way easier for faculty and helps make it easier for faculty to want to do citizen science projects, or it just sort of lowers that barrier again. For me, I work in collections. Negotiating with vendors is something I have to do all the time. And really, guys, these people are so reasonable. It's really, really easy, it turns out, to work with we worked with Reconics, who made the camera traps. We worked with New England Biolabs to get reagents. We've worked with Eppendorf to get pipette tips. We've leveraged existing relationships that we already have on campus with, the Genomic Sciences Laboratory. We know them, we help plan workshops and trainings for them. And we were able to get sequencing kind of at like a bit of a discount rate because they had funds to support education that they were able to offer up because there was a relationship there to try and get that going. So there's a lot. Rely on your networks. Libraries are very, very networked organizations. So reach out to the connections you have on campus, and there's tons of relationships out there. And negotiating with a pipette company is way more fun than negotiating with certain other vendors that libraries work with. So next slide, please. All right, so thinking about instruction support, right? Helping to set up instruction is another aspect where we've got a lot of resources that already exist and they just need some reworking. So we've refined some of our intro to library instruction sessions to focus more on challenges unique to citizen science, which, surprise, are not wholly unique to the challenges of doing research. They just need to be framed differently. We've also had the opportunity to expand some of our more quote-unquote advanced tools-based workshops. It took looking at the projects and the research skills they drew on and then comparing that against existing library offerings. So we never had to build anything from scratch. We had that long view of the project and were able to say, what could we retool to fit in with this? So we had a class that needed to find scholarly articles about a project they participated in and an instruction session about researching a topic that's not firmly scoped or that's new to you. We had an upper-level class that would be using nucleotide sequence data to identify microbes, and a workshop on sequence and alignment searching that maybe other students would also be interested in as sort of like a walkthrough experience of how those identifications were made, and to just be more fully integrated into the full research experience beyond, swabbing some slime in a drain and handing it off. So finally, helping to plan and organize and promote platforms for students to share their work with other students is really, really amazing. It means that it means a lot to the students who present, that their work is taken seriously, that people are interested in something that maybe could have felt just like a class assignment, and it matters to the students who participate. They signed up because they're curious. Research can have very extractionist, very colonial impacts on the communities where research is done. This is a problem that the field recognizes and is working to correct. Citizen science is one field that especially makes constant efforts to acknowledge that harmful history and correct current practice by consciously and critically engaging with communities who are impacted by research or who are themselves part of your research. It's an important form of best practice for the libraries to show up and help model and support that work as part of the research life cycle. So new generations of scientists understand that this sort of final presentation type of report to the community that they studied or that supported them is a normal part of how you do science. This needs to be part of how we plan, and then it needs to be something that we continue to examine and refine, which brings us to evaluation. On the next slide, please. Thanks. So evaluation methods can, again, be multifaceted depending on the courses you're working with and what kinds of integrations they are. This is also an area where we've relied heavily on SciStarter and on collaborations with our College of Education. So you need to be able to track who's signed up and whether or not they're part of a class. Most of our projects are open to the whole campus community, so we have people signing up who are part of a class that's doing it as a requirement, and we have people who are signing up because they're just generally interested. You need to be able to track and differentiate that. You also need to see just in general how they're progressing through any training, through submission processes or reflection phases. Do they currently need or have materials? That kind of thing in general. We've been really fortunate to have an integration with SciStarter through a grant from our College of Natural Resources, and that's really how we've managed to track all of this across multiple courses and broad campus participation. So we also measure learning outcomes for students collecting data and students in classes working with the data. We've used a survey designed by graduate students in the College of Education as part of their own coursework. They mishmashed together a bunch of existing survey tools so that we could measure science affinity, science agency, and science efficacy without having to survey students multiple times and making it more likely that we get actual responses. But then there's also course objectives to consider. Is citizen science working as a holistic experience for students, but also is it working for the class? You can take all of this assessment as internal program assessment or as IRB approved publishable data, and we've used it to apply for more competitive grants and to entice new collaborators. And now I'm going to turn it over to Megan, who's going to talk more about supporting those new collaborators once you've lured them in.
Hi, everybody. Thank you so much, Danica. You're awesome. I love hearing about putting these in classes. So I'm Megan Carlton. I am the science librarian and the liaison to STEM areas at UNC Greensboro. So I'm going to talk about how academic libraries can support the creation of citizen science projects with faculty. Some of the steps may actually be solely on the researcher to come up with, but I really think it's a good idea to kind of recognize that entire process that goes into designing a project from scratch. Next slide, please. So the most important aspect, I really think, in not only coming up with projects for classes to incorporate, but also in that design process, is to really be familiar with a lot of different types of projects. That means really get out there, play with different projects, be involved in different projects, and to really be familiar with a lot of different subject areas. So I talk a lot about projects surrounding biodiversity and ecology because that's where my interests lie. But really this barely touches the surface of different topics that are covered by citizen science. These are screenshots from a couple of examples of how projects could really vary across disciplines. The top left image is a spectrogram from the Gravity SPY project that is studying ripples in space-time. It is showing a glitch, which is a signal that can hinder the search for gravitational waves. And classifying these glitches is being used to train machine learning algorithms to spot glitches, and then that frees up humans to classify any abnormal glitches. The next picture is from the Power to the People project. In this one, participants are just asked to draw boxes around possible homes and buildings on satellite images in order to find rural homes in Africa to expand electrical access. The top right is an example from the Anti-Slavery Manuscripts project, in which handwritten correspondence between anti-slavery activists in the 19th century are being transcribed by volunteers. The bottom right is the Fishing for the Past project, and they're learning about biodiversity and the history of our culture by looking at the use of fish in the past. As participants look at paintings from the 16th to 19th century, they identify whether or not there's a fish in the painting that could be recognized by scientists as a specific species. And then the last one on the bottom left is from the Penguin Watch project, in which participants are helping to kind of understand penguin population changes, behavior, and timing of breeding. So next slide, please. So once you're kind of familiar with a lot of different projects, it makes it easier to kind of see where a faculty's project might fit in and what that end might look like. So the first really like essential step in planning and brainstorming is to answer broader questions about what the researcher is trying to accomplish. I generally start by asking just two questions. So what data do they have and what data do they need? So for example, the UNCG Wetlands project has more than 4 years of camera trap data that was so voluminous they couldn't even do anything with it. They wanted to know about the biodiversity around the wetlands on campus and needed the species in the pictures identified. But their research team, they had like 4 graduate students looking through thousands of pictures, and they just could never really make headway on it. So the data that they had were these pictures, and the data that they needed was species identification. From the other direction, the tree snap team from the University of Tennessee and the University of Kentucky is working to understand what allows some individual trees to survive, but they need to find healthy, resilient trees in the forest to study in order to build a better tree breeding program. So that one, the data that they have all this knowledge about, what they are looking for in trees to build these breeding programs, but they don't know where those good candidates are. So they're asking participants to go out in the field and take pictures of specific tree species. So both of these projects are really great candidates for public participation. And again, if you're already involved in a lot of different types of projects, you may find when you discuss with faculty that their project is very similar to one that's already out there. So this is kind of how the UNCG Wetlands Project went from stalled to jump-started. The PI on the team had no knowledge of citizen science projects or even what they looked like, and during an informal meeting I showed him a Snapshot Serengeti project, which those of you who came to our webinar last week may be familiar with, and kind of how the public can assist in processing that camera trap data. So whether it's processing or collecting data, this sort of breaking the project down into simple and distinct tasks can really help researchers clearly identify objectives for the project and participants, and also can help you start thinking about workflows of the project. So next slide, please. So while you're still in the planning stage, it's important to think about what the outcomes of the project might be. So outcomes are measurable events such as skills or abilities or knowledge that result from specific outputs of the project. So these are kind of in three categories, and these might be and probably should be something that the researcher is coming up with, but it's also good, you know, if you've participated in a lot of projects, that you will be able to give some input as to, hey, well, participants generally can kind of get this outcome from a project, and to help kind of brainstorm with the researcher. So these outcomes are those for science, those for individual participants, and those for kind of social ecological systems. So the outcomes for science is the clearest one, I think, that, you know, citizen science projects have really advanced scientific understanding about, you know, trends in species ranges and diversity, and then the spread of disease and invasive species, changes in life cycle events, as well as implications for aspects of human health. These projects have also really contributed to innovative and enhanced techniques for collecting, analyzing, and managing data. So outcomes for individuals, though, can look a lot different, and it is something that you need to think about. You know, you're asking people to volunteer in this project, and what are they going to get out of it? So these can be, you know, anything from new skill sets or an increased understanding of just the process of science, and it can give you opportunities to deepen relationships with the natural world or with other people. Again, these are important for researchers to think about as they want to build excitement and participation in their project by offering the participants something in return. And yeah, I see a question about COVID projects, and I have seen several of those pop up, and it just depends on how involved you want to be in. And yeah, we can talk about that at the end. I'm sorry, I got excited because of some that I've seen. So also there's outcomes for social and ecological systems, and this can look like, you know, improved relationships between communities and management agencies, or maybe backyard enhancement of wildlife habitats. And then just an increased likelihood that participants will maybe engage in the policy processes to improve their communities. So not all of these projects will yield outcomes in all categories, regardless of what your goal is. Some of the projects will be achieved, and some projects will have completely unanticipated outcomes, but it's still something to discuss and keep in mind while planning. Okay, so next slide, please. So we can also help out with just the design process of these projects. So once again, and I promise last time I'll say it, but being familiar with a lot of types of projects and how they work really goes a long way. So far in citizen science, there are 4 main types of projects. Web-based projects are just that, projects that can be done completely online, such as a camera trap project and many others. They don't require participants to go into the field or leave their computer, and the platform's universe contains only these types of projects so far. So these projects are designed to appeal to the widest range of volunteers and are typically asking participants to do simple tasks, but it can process large amounts of data. So the other side of that are field-based projects, in which the researcher relies on data collected by the participants. The variety of these types of projects can range from collecting and analyzing water and soil types, taking measurements, pictures, or sound clips, monitoring urban areas, to growing mold, and just many, many more. So you are really only limited by your imagination when it comes to developing these types of projects. But the one thing to keep in mind is that they really require an attention to explaining collection protocols and best practices to participants, and really thinking about ways to ensure the quality of the data you're collecting. Community-engaged research projects are driven by scientists or research team that engages the community to help develop research questions, design the study, and collect data. The goal of these types of projects is to address a community concern through collaborative research and to translate those research findings into public health action that benefits the community. There is a reason for the pig picture under that one. So there's a community in North Carolina that developed a project with researchers at Chapel Hill to address the smell and waste concerns from living near industrial hog farms. With researchers, they tracked the smell at various locations for months, maybe years. I haven't looked at all the studies that came out of that project, but they wanted to build a case about environmental regulation around the farms. The Community Health Effects of Industrial Hog Operations project found that rural communities of color are over 3 times more likely to live within 3 miles of an industrial hog farm compared to white communities, as well as numerous public health concerns that needed to be addressed. Projects like these can really assist communities in policy development and change within their communities, as well as provide research opportunities for scientists. So the last type is citizen science games. So this leverages the ability of users to solve puzzles and can range from finding the best trajectory in a city with traffic, to identifying genes, to folding proteins, and the one picture here is EyeWire, in which participants mapped 3D structures of neurons within the brain. And I think there is actually a protein folding project for COVID, where you are assisting in trying to find a vaccine and really understanding genetic something. But I can find that project in a few minutes. Okay, next slide, please. So when designing projects, it can really be helpful to highlight characteristics that contribute to project success and to keep those in mind throughout planning. There's a paper by Chase and Levine from 2016 that outlined 52 programs and determined that there were really 4 main categories of characteristics that influence citizen science programs. Of these, a few emerged as critical for fostering a supportive environment for successful and enduring programs. And they were accessibility to the resource, having multiple coordinating institutions and diverse partnerships involved in management, and the strong presence of at least one characteristic that indicated a social or cultural importance. Next slide, please. Oh, I'm sorry. Christina, this one is a Chase and Levine, and I will drop it in the chat in a second. My citations didn't make it onto the slide. I think they're in the notes. Next slide. Oh, wait. Never mind. That's it. So since these diverse partnerships are so important and highly influential to, whether or not a project's going to be successful, it's really worth putting forth an effort to kind of build these partnerships. In the same way that Rome wasn't built in a day, projects aren't typically built by one person. The Box Turtle Connection is a North Carolina state-level initiative of the Box Turtle Collaborative. And this is a group of biologists and education professionals that are partnering to improve public understanding and to collect scientific data on populations of eastern box turtles found in North Carolina. So this collaborative includes representatives from 2 universities, including UNC Greensboro, and 4 state agencies. The group came together in 2007 and initiated this plan to collect data on box turtles around the state. So this long-term monitoring project, though, the reason there are so many people involved is that they're really hoping to outlive the youngest person in the project, so that in 100 years, the turtles and their offspring will be educating the next generations of scientists, and these partnerships may enable this to happen. But again, partnerships, sorry, I'm trying to move quick. So these partnerships can't really do anything without the volunteers and participants. So next slide. And so when planning, you really have to think about the stakeholders and the participants. So things like, what will those participants get out of your projects, and what skills and resources can they offer, and including how much time they can have to offer. This is why it's really great to incorporate these into classes, because you have that captive audience that needs it for a grade and will try to do good work, and you may have, you know, a lot of participants out of including them in classes. So really you want to kind of evaluate the participants and the communities that you're trying to get involved in your project and find out as much as you can about them. Next slide, please. And lastly, that I really only want to mention is data management. As you know, this could be an entire webinar on its own, but since data collection is the primary goal of most citizen science and crowdsourcing projects, and librarians at the same time are growing in their ability to offer data support, this is a natural place in the process where librarians can support faculty citizen science projects. So to find all of these projects and more, I will pass it over to Dan and Caroline to talk about awesome SciStarter.
All right, let's go right to the first slide, if that's okay with you. So really briefly, I wish we had time to demo this, but so at SciStarter, for those of you who attended last week, you know, for those of you who are new, welcome. SciStarter is a place for people to discover citizen science projects that need their help, but we also create a number of resources for facilitators and project owners. So project owners, the people who lead those citizen science projects, can add their projects to SciStarter if they're looking for participants, and facilitators, be they librarians, library staff, educators, parents, troop leaders, and more, they're able to use tools on SciStarter to help get their community involved in citizen science. One of those tools, which we just made, and we're hoping you all will help us test it, is called Lists. In the follow-up, the resources that go out afterward, I know Kelsey's sending a link to our Lists how-to. We wrote a blog post about the best way to use this feature, but very briefly, by making a list, you're able to track and ID participation on SciStarter for people who have public accounts and for people who click on the projects in your list. So you can look at the thousands of projects in the SciStarter Project Finder, and you can add any of them to a list. You know, you may have done this before on like Pinterest or Goodreads or websites like that. Now you can do it with citizen science projects, and you can share that with others. And for the projects on that list that are affiliate projects, those projects that have gone the extra mile to work with SciStarter to assess collective impact and allow people to keep track of their participation in their SciStarter dashboard, the number and frequency of their contributions. You're able to see from analytics, just the list owner can see those analytics for users who are accessing projects on that list and the number and frequency of their contributions. You have to be over the age of 13 to have a SciStarter account, and there are other privacy protections as well. You can opt out of having a public profile. So you'll learn all about that when you read the List how-to blog, but we hope you use that, and we hope it's useful, especially for library staff and educators, because you're the people we were thinking of when we made this tool, and we made it specifically to respond to COVID. So next slide. Yeah, so we also have a SciStarter Education page, which we also made to address, our new normal here, the new what's going on in the world. It's the SciStarter Education page. These are projects that we picked out. We had our education advisors pick them because they either have classroom materials or are particularly good for a different grade level. So you can find some projects for college students on that page, SciStarter.org/education, that we think would be a really good fit for your college, for your academic library environment. So let's go to the next slide. We also have a number of how-to videos. We encourage you as academic librarians and library staff to use these videos in your programs. These are webinars recorded by libraries, museums, community groups, and more. So you could take a pre-existing recording that we've done with a project scientist, and you could use it as a virtual volunteer opportunity. And in fact, NASA Goddard Space Center, they used one of our recordings with Canadian citizen scientists as a virtual volunteer opportunity, so the staff was able to watch that and get 1 hour of service time. So please go to our videos page, SciStarter.org/citizen-science-videos to use those resources, and we hope that they're helpful for you. So let's go to the next slide. We're also doing summer reading right now, and I actually just came from an event. It's very fortuitous because Megan talked about in her presentation a project that was addressing COVID, and one of those projects is Eterna, and that was the summer reading event we just did. So we're doing 12 events in partnership with public libraries all across the country, supported by NNLM, with the theme of Imagine Your Story. And all of these events put public librarians in conversation with project leaders so we can make these projects more accessible. We can learn a little bit about the project leaders and their stories, and we can all get started doing these projects. And all these projects address human and environmental health. So there's Foldit, and Foldit's on the NLM page, and it's actually featured in the summer reading. And there's also Eterna, and they both address COVID, which is cool. And there are other projects like Crowd the Tap, which addresses tap water, and all sorts of amazing projects that you can discover through Imagine Your Story. All right, let's go to the next one. Citizen Science Month 2021. It's coming up sooner than you think, April 2021. It's a party and academic libraries are invited. We also currently have some social media takeovers ongoing. So each week, a different person grabs our handles at CitSciMonth on Instagram and Twitter. Last week, it was Meredith Palmer, who's a postdoc at Princeton, and she leads the Snapshot Safari projects, which you heard about on last week's webinar. So she took over. Those are really fun tweets if you want to look through those. But we encourage you all to take it over, too. We want more academic library representation. So if you go bit.ly/CitSciMonth takeover, that is a case-sensitive URL, FYI. We hope that you sign up and start sharing all the amazing things you are doing in the academic library space with the global citizen science community. We also have weekly Thursday office hours. Feel free to come join me. Those are at 8 a.m. and 11 a.m. Eastern on Thursdays, and you can sign up for them at citizensciencemonth.org. So next slide. And library resources. So at SciStarter, we have amazing partners like Arizona State School for the Future of Innovation and Society, and the network of the National Library of Medicine and more, who put together library resources, and our goal is to share them with as many libraries and library staff members as possible. So we have tutorials that are open access that you can share with anybody. We have the Library and Community Guide to Citizen Science, which you heard about last week, which is about a 40-page document that we update pretty frequently, and so much more. So we encourage you to check back at the SciStarter.org/library-resources page, because we add more things all the time. So let's go to the next slide. And now I'm going to hand it over to Dan.
Thank you. And I just popped in there another thing that folks may be interested in. You know, SciStarter has a great blog that you can check out, and it provides information about what people are currently doing, information about particular aspects of projects, things like that. And I know that Caroline is always looking for people to write blog posts, so it's also a great way for you to get your name out there as somebody who is writing about citizen science. So with mine, if you could follow along, I know that they sent out the resource links earlier. Rather than click on these or post the links into the chat, I'm just going to kind of move along and kind of point to these links, and you can follow along yourself. So my esteemed colleagues have been demonstrating a number of ways that academic libraries and librarians can actively promote and support engagement in citizen science projects with faculty and students. And I think you will all agree that there's lots of ways to approach this. Now, if some of you are unfamiliar with citizen science and how it might work in there, what kind of resources do we have for you to help you feel a little bit better about checking it out closer, researching it a bit, and sharing that information? And one thing I will say is, obviously, you know, with global warming and now with COVID, science literacy is a very important and critical resource. And so more than ever, we can point to that as a good reason for citizen science. So what I'd like to do now is to take a look at some key resources to promote and support your engagement in citizen science, especially if your level of connection and collaboration with faculty and students isn't quite there yet, or if you need to formulate a plan and pitch it up the chain of command to even begin working towards a level of collaboration such as that we've been highlighting. So what are the values and priorities of your institution with regards to faculty and student engagement? And I'm assuming everyone is familiar with ACRL's framework for information literacy for higher education. And you know, it may be that your library has already adopted or adapted the framework as core concepts and skills, and that's great. So that may make it easier for you to demonstrate where and how citizen science activities kind of fit into that accepted structure. If your library does formally follow the framework, or if it's been a while since if your library does not follow the framework, or it's been a while since you've looked at them, please take a look at the ACRL framework for information literacy for higher education. These are written for us in our language and about our circumstance. And so it's a good way to get comfortable with the concepts. And some of them, you know, the big concepts are basic, and then they dig down in there, but it's a great way to start and get that understanding and then make your pitch, you know. So I won't go through them all, but authority is constructed and contextual, information creation has a process, information has value, research is inquiry, so on and so forth. So that's a good resource for the general, very big picture. What about science? As I mentioned previously, I should also introduce myself. I am a research and engagement librarian at Arizona State University. I am not a science librarian. And so I would argue that it may put me kind of at a disadvantage in discussing science. It's not insurmountable to not be a science librarian and dealing with citizen science, as long as you understand this and are willing and able to ask questions and see where things are. So if we look again at ACRL as an overall professional base, the Science and Technology section, STS, is the home for science librarians, and a great place to learn and keep up with how science and technology are and can be done in academic institutions. There's a lot of information on that site. There's a listserv for asking questions. It's really good stuff. And then, so the intersection of science and technology and information literacy, back in 2006, prior to the adoption of the ACRL framework in 2016, the STS group took a look at information literacy and created a set of standards for science and engineering and technology. So while that's somewhat dated, there is value in reviewing the science-specific information literacy concepts. Next slide, please. So another great resource is the Citizen Science Association. And it focuses on citizen science, advancing knowledge through research and monitoring done by, for, and with members of the public at its core. So as we learned last week, citizen science isn't new, but the existence of a professional association, not to mention others in Europe, Australia, Asia, as well as a lot more activity in Africa and South America, shows that this activity is legitimate and supported by researchers, government officials, educators, and the general public. So at this site, you get to see the ongoing progression and have the opportunity to learn from and interact with those using citizen science, not only to add to scientific knowledge, but to engage communities. So many members are quote-unquote scientists or academics driving the scientific research. There are also those who promote lifelong learning, transferable skills, science communication, all important pieces of citizen science. The CSA also has its own open access, peer-reviewed journal, Citizen Science Theory and Practice, a great place for academic librarians to research citizen science, the issues, the challenges, the successes. It's also a great place to make some impact by contributing from a library perspective. Libraries have an opportunity to become players in shaping this inclusive form of research.
Kind of incorporate.
And I'm getting a little feedback there. I'm not sure if everyone's muted. So citizen science is growing, and the CSA works to highlight and openly discuss these issues to improve the practice. Over the past year, they have hosted a number of webinars on topics ranging from legal and ethical issues, data quality, responses to COVID, and my favorite, faculty members discussing how to incorporate citizen science into your hybrid course. That's that final link there. So think of it, you get to listen to faculty speaking to other faculty about their challenges and best practices, and that's a great resource to take a look at your role or your aspirational role as a librarian in supporting this. Next slide, please.
I think the panelists need to mute. I can hear, or I don't know if the sound's coming from a participant.
I'm not sure who it is either. But I'm going to keep going because we're almost out of time. Next slide, please. Oh, I'm sorry, you got it. Finally, what can you do on your own to get started and get the word out? So we do library guides.
If you would like that stuff to live with me.
Can someone mute themselves, please? I'm not sure who's talking.
I'm not even seeing anyone who's unmuted, so I'm not really sure what's happening. I apologize.
Dan, do you think a video might be on your screen on accident? That sometimes happens to me.
I think that I brought it. I think Brian might have grabbed it.
Well, I'm going to keep going here. You can do a library guide. Start small. I've got my library guide up there. You can do news feeds. You can do book lists. You can link to webinars, resources. You can highlight state and local activities with citizen science. You can start to build your own local network at your institution. Citizen science is growing, but like us, a lot of the practitioners are kind of coming at it by themselves. Get together, network, share information, share resources, share best practices. Host your own event. The link on there. Citizen Science Month is in April. Caroline and SciStarter are at the ready to assist. We can get going with stuff to get you ready for April of 2021. And what would you like to do to promote citizen science at your academic community and beyond? We also have the Citizen Science, Introduction to Citizen Science module to point to and to point others to so that they can kind of work through at their own pace what is citizen science and how they can participate. And then lastly, if you're really daring, you can always take it upon yourself to teach a class about citizen science. So speak with your academic units and see what they would like to do, what it would take to launch a formal course. And just one word of caution that I am sorry, but Darlene Cavalier is working with me. Thank you. Pass it along to questions.
All right, and we also have a survey that I'm going to quickly drop in the chat that we hope you all fill out. You're, of course, you're not obligated to, so I'm going to drop it in there now, and then let's get the questions going in our last minute.
Yeah, if I don't mind staying around for a couple of extra minutes. We can keep recording for another 5 minutes or so if we have some questions to answer. But if you do need to leave at 4, we won't be offended, and feel free to duck out. But if you have questions, do type them in the chat, and we will try to answer some.
So the survey's in the chat. It's case sensitive. It's bit.ly/academiclibrariesrock. So please fill that out if you can.
We can wrap up. If you come up with a question afterwards, please email me, kac221@pitt.edu, and I would be more than happy to direct your question to any of the panelists as appropriate. So thanks for spending your Friday afternoon with us. Sorry we had a little technical difficulty at the end here, but hope you'll have a great weekend and thanks for coming.
Thank you so much, Kelsey.
Happy
Bye,
Friday.
everybody.
Bye.
Great. Thanks, everyone.
Thank you.
Thanks for watching. This video was produced by the network of the National Library of Medicine. Select the circular channel icon to subscribe to our channel, or select a video thumbnail to watch another video from the channel.